Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we have got Diego, who has just completed the course Linux Basics, Linux for Robotics, and he will be giving us a presentation on that. So first of all, we're gonna begin by seeing a demonstration of his code base running on the real robot, and then after that we'll get to ask him a couple of questions. We'll also be asking as we go, because then the ideas will still be fresh. So let me now hand over the platform to him so he can begin his presentation. Okay, Diego, whenever you're ready.
Perfect, thank you. I just have to wait 22 seconds so that I can connect the real robot.
Okay, alright.
Well, the bring up program is all ready, so we're going to see how the robot is moving here.
Are you... Oh, you were running this in simulation earlier.
Oh, this is just like the simulation of the real robot.
Okay.
Right now, I am connecting to the robot.
Okay, alright. So you will probably do the same thing.
Okay.
Alright.
Okay, well, okay, it's ready. Now, let me just test if I can move the robot. Okay, it is working. Now, right here. Okay, so first of all, I am going to run my interface file. This Linux Basics project again, and in here we have three files: the robot interface, the robotics, and the obstacle avoider. So in order to work with the robot, I am going to launch my robot interface. It's going to get ready. Okay, now using the same path,
I think you forgot a space there, but yeah, there we go.
Yes. Okay, this is another terminal, sorry. I don't know if I copied it. It's Linux Basics.
Try using tab to autocomplete for you.
Oh, perfect.
Yeah.
Okay, now here I'm going to run my the obstacle avoider. So there you go. It should connect to the node, and yes. So the robot should start moving once the parameters are set. In here, it's getting the scan ranges: left, front, right, front, left, and right. So in here, it's turning right, and the robot, it should be turning right. I don't know if it's...
I think...
yes, it's moving.
Okay, please, can you make that screen bigger so you move your terminal more to the right? So we can see that the robot is actually moving. So.
Okay, there it is.
Okay.
Also, I am going to run my statistics bash. So, and it is called robot statistics.
Okay.
Okay. And in here, well, as you can see in both programs, I am getting the angular velocity. But I decided to include in my avoidance the range count just for fun. And in the statistics patch, I have all the geometry, position, orientation.
I think I lost you there, Diego.
Depending on the robot interface.
Okay.
And there you go.
All right. So I think, okay, just give me one more sec
here. Well, as the course says, it is the probability of it for crashing is a little bit high or getting stuck.
yeah. But you must do your best in the algorithm to make sure that you at least avoid those edge cases, right? Even though it's naive.
Yes. yes, and that's actually like the importance of deciding what action to take with the conditions.
Okay. All right, but it's working pretty well so far. I think it's managing to avoid the movable obstacles there. Those are the most difficult ones, at least. Let's see if it avoids this one.
Okay. Right here. Okay, front is not free, so it's going to check for left and right, and it says, oh, I'm turning right because right is the distance comparing right and left. Right is bigger.
All right.
So I'm going to turn right. There, it's this little obstacle.
Yes, I noticed that.
Was in the front left range, but I don't know if it didn't detect the obstacle. Actually, we can see in here, moving forward. Okay, you get that the three ranges were free, so it moved forward. I think it didn't detect the obstacle.
That it was there. Okay. Yeah. It can be very difficult with these movable obstacles as a result of their structure, right? Because they are very thin in the middle, and then there is the sign at the very top and the wider base at the very bottom. So yeah. All right. Other than that, it looks to be doing very well. And you mentioned also having the laser scan data be given to you in the console as well.
Sorry, can you repeat the question?
The distance that's being given. So whenever it publish the distance that's furthest in the console. For example, we see that the first message that you get is one that says distance and direction, right? Is that the front index that is being considered? That one, yes.
Front index. Well, the distance is the distance traveled since the robot started moving.
Oh, okay.
The avoidance program started.
Okay. So that's cumulative distance.
Yes.
Oh, okay. All right, I see.
Actually, the distance between each movement is shown, for example, in here. Distance to move, 0.306 meters.
Oh, okay. All right. Okay,
so this is the distance that we will add to the next accumulative distance.
Right. Okay. Very nice. I like this implementation. I like it a lot because it says it gives all the major parameters, right? You don't have to look very far to see them, to see what's going on, right? So when someone asks what was the previous distance that it picked to be the furthest, you can always look into what the terminal is giving you, and you see that. So well done on this one. I really like this bit. All right. I think you can stop this obstacle avoidance script, and then we'll get into what it is, what it looks like, how it's written, and the logic behind the way it was developed.
Okay. Well, now going into my code, there are 3 main scripts. These are the 3 bash scripts. So the first one is the obstacle avoider. The second one is the robot statistics, and these 2 depend on this robot function .bash. As we know, well, the bash files, they allow us to write several command lines and run them at the same time. So in this case, in my robot functions, I have all the functions that are getters and setters for the odometry, emu, scanning, the LiDAR. And I use these functions in my obstacle avoider bash to stop the robot, for example. I use a threshold. And I decided to make these little functions to englobe these movements for turning left, turning right, and moving forward.
Okay.
So,
also you call them whenever
1.5 seconds.
Okay, I see.
Yes.
So you call
yes, I call them in here
when you're setting the parameter values for the angular and linear velocities.
Yes. I'm calling the functions of the robot statistics.
Okay. All right. Yeah. Innovative. Yes.
And well, here is turning right, turning left, left, right, moving forward, and well, I stop after every action so that the robot does not go far away.
Okay.
And in here, I also call the getters in order to use, for example, this is the angular velocity in J, and the count of well, the ranges count number, just for me to practice and to know, because in the statistics bash I do not have this count range, and I saw it in the information given in the course, and I wanted to include it, so there it is. Here is the information that I get from the scan ranges, and I use this in order to check for the conditions. So the front left, front, and front right are the ones that are going to be compared with the threshold.
Okay.
And depending on these situations, if the threshold is bigger than the scan range I got, it means that the scanner, well, the robot is detecting something, an object in that range.
Okay.
So it is going to be a 0 logical or a false.
Okay.
And I have 8 cases. So depending on each cases, for example, in this case that I am not pretty sure where to go because every scan range is occupied by an object, I have to decide in turning left or turning right depending on the comparison between left range and right range.
Okay.
And that's what I did. So, for example, if right is free, well, I'm turning right. If front is free, move forward. If front and right are free, well, I decided to turn right. Also with front and left, I decided to turn left. And I did the same comparison between left and right in cases that front was blocked by an obstacle.
Okay.
And that's the program of obstacle avoider. In the case of robot statistics, I just called the functions that I made in the robot functions bash. So I get this data that it's actually a ROS command line.
Yes.
So this parameter stores inside, for example, distance, and then I echo distance into the shell.
Okay.
That with every parameter.
Okay.
And that's all.
All right.
And this one is important because I use the source function in order to run every command line in the robot functions bash so that I can use these functions.
All right. Thank you very much. All right. So, do you still have any other bits that you want to speak about, or that's it on your side?
And that's it.
All right. So, I'm gonna ask you a couple of questions with regards to this, and also we are trying to probe for the knowledge about Linux, right? So, the first thing I would wanna ask, I noticed that your base scripts, right? They are green, right? Can you explain to me the procedure of making them executable, right? Because if they are highlighted green like they are, right, it means they are allowed to execute. How do you change that status?
Yes, of course, right in here.
Yes.
Okay. They are green because I made them executable. That means that I used this command, chmod. And for example, using the X, I can change to executable any file I want to.
So you can then give the file name.
Robot functions bash. It is executable for the proprietary, for the group, and for any person that I want to. So anyone can execute this program. I can decide if I want them to if I can allow people to execute, to write, or to read these programs.
All right. So if we are going to change the execution capability for the group, how would you do it?
Okay. It is with chmod. Just here. I have these. Let me take my notebook just first, quickly.
Okay, no worries. Okay, so wait for him to get his notes, and then we get to see how you will be able to do that. So.
Okay, so for this, in here, for example, I have this execution before this line.
Yes, the stroke.
I'm going to write the stroke. I'm going to write the group I am going to modify. For example, U is for the proprietary, G is for the group, O is for others, and A is for everyone. So if I make G stroke X, and the name of the file, I'm going to modify specifically the group section, making it executable for the group.
Okay, is it stroke X or plus X? What are you making it executable or removing the execution?
Sorry, this is for removing and this is for adding.
Yes.
So it's T plus X.
All right. Thank you so much, Diego. That was very brave of you to rush and fetch your notes, but yeah, well done. We wanted to know that bit because it's very important to be able to know, okay, how do you modify execution criteria, right? So, and can you explain to me what W represents in that list of permissions?
Oh, sure. W represents writing.
And
so, for example,
yes, go ahead.
Sorry.
Yes, I like that example. Go ahead and explain. Yes.
If I create another script, for example, example bash, and I can go inside this script.
Yes.
And right in here, I can modify it.
Okay.
For example, if I go to insertion, I can write, for example, read me, and then okay, and then I go out of insertion, I save and I quit. I did it because I was able to write this script.
Yes.
So if I go in here, example, for the proprietary, it has a W because it has the write option.
Right, yes. But for the rest, it's all read, which means they cannot be able to make changes to that file, correct?
Yes.
All
Yes, the
right.
group and the specific person cannot
Yes,
write
wonderful.
the file.
Wonderful. Thank you very much, Diego. It's been a nice presentation, and thank you for the job well done. So congratulations on that bit and explaining clearly. All right. So just hang on and we'll wrap it up here, right?
Okay. Thank you very much.
Sure. All right, everyone. This was Diego's presentation, and we'd like to congratulate him for the job well done and for also educating a lot of us about what you can do when you want to change permissions and do other things in the Linux command line. We think this is very important for everyone to know. If this is the road you want to take, it is also quite important to understand these principles. So until next time.